Hey everyone, welcome back to the channel MLT Lectures, where we discuss everything related to Medical Laboratory Technology course. So don't forget to subscribe to our channel and hit the bell icon to get the notification whenever the new video is uploaded. In today's video, we will be discussing about hematoxylin and eosin stain, which is the most important part of a histopathology lab. Now, let us learn about the introduction. Hematoxylin and eosin stain. It is the most widely used stain as a histological stain. Hematoxylin components stain cells, that is nuclei, blue or black in color with a good intracellular details, whereas eosin stains the cell, cytoplasm and the most of the connective tissue fibers in various shades of pink, orange and red. Now let us look into detail firstly about hematoxylin and we will go for eosin the next. Hematoxylin, it is extracted from the core of a tree, that is Hematoxylin capucinum. Hematoxylin is a Greek word where hematol means blood and xylon means wood, referring to its dark red color in a natural state and to its origin, that is from a wood of a tree. The hematoxylin is extracted from logwood with a hot water and then precipitated out from the aqueous solution using urea. Hematoxylin is a misnomer. This is naturally extracted from the logs. Hematoxylin is not an active dye. Hematoxylin is extracted and it is later oxidized to hematin. Hematin is responsible for staining properties. In the process of oxidative conversion to hematin, hematoxylin loses two hydrogen atoms and assumes a cunoid arrangement in one of its rings. This is the structure of hematoxylin. After losing two hydrogen, it forms hematin. Now, there are two types of hematoxylin, naturally ripened hematoxylin and chemically ripened hematoxylin. There is a difference between these two. First, we will discuss naturally ripened hematoxylin. These are ripened by the exposure of light and air. It takes 3 to 4 months. It is a slow process. This naturally ripened hematoxylin has long shelf life and retains stability for a long time. Examples of naturally ripened hematoxylin are Eldridge hematoxylin and dilapide hematoxylin. Next, we go for chemically ripened hematoxylin. These are ripened by the exposure to chemical oxidizing agents. Ripening is instantaneous. It does not take a time. It is ready to use immediately after preparation. It has shorter shelf life. Example of chemically ripened hematoxylin is sodium iodide in Mayer's hematoxylin and mercury chloride in Harris hematoxylin. Now, this is the very important part of staining, that is principle of mordant. We know that hematin is anionic and tissue is also anionic. Therefore, these two have poor affinity towards each other, being both anionic in nature, making hematin inadequate as a nuclear stain without the presence of third element, mordant. So, mordant forms a link between the tissue and the stain. Some of the mordants that are commonly used are salts of aluminium in the form of potash alum or ammonium alum, salts of iron, salts of tungsten. Less commonly used mordant are salt of lead and salt of molybdenum. Now, classification of hematoxylin. Earlier, we studied classification of hematoxylin on the basis of natural oxidation and chemical oxidation. Then we learned about the mordant used. On the basis of mordant use, there are alum hematoxylin, iron hematoxylin, tungsten hematoxylin, lead hematoxylin, molybdenum hematoxylin, and hematoxylin without mordant is also there. Now, alum that are used in types of hematoxylin are Eldredge hematoxylin, Mears hematoxylin, Harris hematoxylin, Gill's hematoxylin, College hematoxylin, and Karazi hematoxylin. Mostly in the laboratory, we use is Harris hematoxylin. Another very important point to know during learning of hematoxylin and eosin stain is alum hematoxylin can be used in two ways, that is regressively and progressively. Regressively staining means the section is overstained and then differentiated in acid alcohol followed by bluing. In regressively stain, the section or the tissue is overstained and then differentiated in acid alcohol, whereas in progressively staining, they are stained for a predetermined time so as the adequately stained by leave the background tissue relatively unstained. Differentiation provides a more controllable method in removing excess stain from a tissue component and a glass slide. 1 ml of 5 to 10% acetic acid in 99 ml of 70 to 95% alcohol detaches dimolecules from cytoplasm and nucleoplasm while keeping the nucleic acid complex intact. After acid, we do bluing. After differentiation, the hematoxylin with acid alcohol, the nucleic is the tissue are red in color. This red color is converted into blue-black when the section is washed into a weak alkali solution. This process is called as bluing. Alkaline solutions that are used for bluing are tap water, Scotch tap water, saturated lithium carbonate, ammonia in distilled water. Now, deterioration of alum hematoxylin is marked by the formation of precipitate in the stored stain. At this stage, the stain should be filtered before use and the staining time need to be increased. It is advised to prepare fresh batch of stain every month. Next we will learn about eosin. Introduction to eosin. This is most suitable stain to combine with alum hematoxylin. It has ability for proper differentiation between cytoplasm of different types of cells and between different types of connective tissue, fibers and matrices by staining them with different shades of red and pink. There are commercially available three types of eosin. They are eosin Y, ethyl eosin and eosin B. Eosin Y is the most commonly used kind of eosin. Eosin Y refers to eosin yellowish. It is water and alcohol soluble. Addition of acetic acid sharpens the staining. Now major steps that we do in routine H&E are: first we do is deparaffinization, which means removal of paraffin wax using xylene. Next step is hydration. Grades alcohol to water. Then nuclear staining using hematoxylin. Then differentiation with acid alcohol. Then bluing with ammonia water. Counter staining with eosin. Then dehydration, application of graded alcohol to 100% alcohol. Then we do clearing using xylene. Now all the steps in detail. Deparaffinization. Step 1. The slide have been usually been heated before staining to help the bind tissue to the glass and melt away excess paraffin. However, some paraffin still remains and must be removed so that aqueous solution may reach and penetrate the tissue. So, to accomplish this deparaffinizing process, a xylene is used to remove the remaining wax. Next step is hydration. The slides are then immersed in graduating solution of alcohol and water from more concentration to more dilute. Most staining techniques move from 100% absolute alcohol to 95 and then can be entered in water since alcohol and water are miscible. Next step is nuclear staining by hematoxylin. The slides are immersed in hematoxylin solution. The staining time is established at each laboratory is different according to the hematoxylin prepared. If fresh batch is prepared, then the hematoxylin is kept for a little time, and if more than a week or then it is kept for a bit of a longer time. Fourth step we have is differentiation. Following a water rinse to remove excess dye, the slides are immersed in an acidic differential solution. The timing of immersion must be established for each laboratory and procedure to obtain optimal differentiation. The differentiation process is halted by a water rinse. Fifth step is bluing. Bluing is the process of shifting the color from reddish to purple blue by application of weak alkaline solution. As I said earlier, like alkaline solution like ammonium water or lithium bicarbonate. Counter stain by using eosin. Eosin will stain in three shades of pink and red, provide contrast to the nuclear stain, and show many cytoplasmic and tissue elements. Seventh step we have is dehydration. After the eosin step, an alcohol rinse follows. This must be brief as the eosin stone can be diluted by alcohol. 95% alcohol is first used, then followed by 100%. Complete dehydration is necessary to remove the remaining water. Eighth step is clearing by using xylene. Now final step is application of cover slip. When satisfied with the result, the histologist finishes the slide by applying either glass or a tape cover slip. Most routinely, stain use xylene as a clearant. Mounting media is applied over the tissue which serve as a glue to the cover slip, protecting the tissue from the damage and exposure. This procedure of HNE staining of paraffin section is different in various laboratories. The timing is different in different laboratory. Thank you. Hope you like the content. Please like, share and subscribe to our channel.